We are still in Module 13. We are now doing Module 13C. So if you remember, we've been talking about graphing linear equations. And the word linear is Latin for the word line. So we've been graphing lines, and if you remember, there are how many types of lines? That's right, there's 3. There's horizontal, vertical, and diagonal. And what we saw in the last module is that every line has the concept of slope. So we're going to talk more in depth in this module, 13C, about what slope means and how it relates, again, to lines. So if you'll take a minute, please get out your class notes. All right. If we go to our notes, we start with the definition. So as you've heard me say before, slope means the incline or the steepness of a line. Okay, when we talk about slope, we talk about mountains and hills, skiing. We talk about slope when we talk about building a wheelchair ramp. You could talk about slope when you look at the roofs of houses that are triangular. The steepness of that line is called slope. It is a number. Slope is always a number. And as you've seen with graphing, we usually write it as a fraction. And it refers to how you move from point to point. So when you talk about slope, you're talking about the steepness or incline of the line, and you're talking about how you move from one point to the next point. And we saw when you graph lines, you always are moving the same amount. That's what the slope is. Now, what you may not realize is there's 3 different ways to find this number for slope. And that's what we're going to go over today, the 3 different ways to find the slope value. The first way in your notes says use the picture. And I'm a firm believer everything we do on paper can be done by looking at a picture. So let's go up to the whiteboard and take a look at this. All right, everybody, here's my example. I'm giving you A at -2, 4, and B at -1, 1. And those are ordered pairs, or points. And what we can do with points is we could plot them on graph paper. So we're going to get out our handy-dandy graph paper, and we're going to plot them. So if we plot -2, 4, what does that mean? When you plot a point, you always start at the origin. The -2 means to go to the left on the x-axis, and the 4 means to go up 4. And that point would be in quadrant 2. Now we're going to plot point B, which is -1, -1. So again, when you plot a point, you start at the origin. The x value is negative, that's why we move to the left. The y value is negative, that's why this time we move down. And now we're in quadrant 3. And yes, if you connected those 2 points, what type of line would you draw? Very good. You would make a diagonal line. Now, I didn't ask you for this question to graph the line. I asked you specifically to find the slope. So if you're asked to find the slope, the first thing you got to remember is slope is always an answer. That's a number. So what I'm asking you to do is not do any work. I'm asking you to look at the picture and find that number for slope. If you understand what the word means, you'll realize this is going to be very simple. Slope is the incline or steepness of this line. And if you could tell, this line is going down, and it's pretty steep. When you're going to use a picture to find slope, you're talking about movement from point to point. So guys and gals, we do not need to do any work. If you have your handy-dandy graph paper, and I ask you to find the slope, put your finger on one of the points. I'm going to start here. Explain to me how I would move to get from here to here. As you know, on this system, you can't count diagonally. You can only move from point A to point B by either going up or down or right or left. And that's how we're going to do this. I'm going to give you a perfect example of how I use slope in my everyday life. I live in South Bossier, Bipsy's in North Bossier. It would be great if I could drive diagonally to get to work, but I can't. If you know anything about Bossier, between South Bossier and North Bossier is Barksdale Air Force Base. And I'm a civilian, I can't go on the base. So I cannot drive to work diagonally. So for me to go to work, I have to go down Barksdale, up Airline. That slope, it's explaining the movement. When you talk about the movement from point to point, you got to talk about being horizontal, left and right. and vertical, up and down. Now, we know what variable represents slope, m. And we've already heard the catchphrase, slope is rise over run. So when you're explaining the movement from here to here, first you're going to describe the rising. Well, if I'm here, would I rise up? No. So I would rise down. So we're going to count. So if I'm here and I'm talking about how I'm going to move, I'm going to go 1, 2, 3, 4, 5. Don't count where you start. I'm here. As soon as I move my finger, I count. 1, 2, 3, 4, 5. But I didn't rise up. I rose down. So that means that 5 is going to be negative. That means I went down. Remember, the word rise means to go up, and the opposite of up is down. So we went down 5. Now I'm here. I'm still not where I want to be. I want to be here. So now I'm going to run. And running means move left and right. So from here, I'm going to run 1 to the right. So I'm going to put the number 1 because I had to move 1. And because I went to the right, that 1 is positive. That is how you get the slope using a picture. You pick a point and you explain the movement. It's always rise over run. So it's either up or down first and then right or left. Now, because this number is a fraction, they're not going to accept -5 or 1. They're going to ask you to reduce it. So we would say the slope is -5 divided by 1 is -5. Now, it doesn't matter which point you use to explain the slope. Okay? Here's Bipsy, and I just went home to South Bossier. I went down 5 to the right 1. In the morning when I wake up, I'm in South Bossier, I got to get to Bipsy. Explain to me my movement. So if I look here, if I'm here, and I want to get here, now I'm going to rise up 1, 2, 3, 4, 5. So now I'm going up 5, which means the 5 would be positive. So here I am, and I'm going up 1, 2, 3, 4, 5, but I'm not there yet. To get to Bipsy, I'm going to have to go to the left 1 place. Going to the left would make the 1 negative. Now somebody's going to say, well, that's not the same result. Yes, it is. 5 divided by -1 is still -5. So the moral of the story is, it doesn't matter which point you start with. If I ask for the slope, I'm asking you to explain me the movement from one point to the other. No matter which point you start with, we're going to arrive at the same slope value. So far, so good? All right, let's go back to the notes. So now that we understand how to find the slope using the picture, what happens if you don't have your handy-dandy graph paper with you? Well, mathematicians said, you know what? Everything that can be done looking at a picture can be done by doing paperwork. So if we look at our next slide, it says the second way to find the number for slope is using a formula. And I know I put the big M word up there that you have to memorize it. But sweeties, you already have it memorized. I know that looks confusing. Y equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You already have it memorized. Let's go back to the board and let's talk about that formula. Okay, so suppose I want you to take these same 2 points and I want you to find the slope, the movement of the line, but you don't have your picture to draw. We're saying now you can use this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I know you're saying, oh my, I got to memorize that. You've got that memorized. If you know slope is rise over run, you know this formula. Because think about it. What does rise mean again? It means to go up or down. If you go back to the picture, which axis goes up or down? The y-axis. So that's why in the slope formula, the y's are in the numerator, because rise is in the numerator, going up and down. Running means go right and left. So if you look at your graph paper, which axis goes right and left? It's the x-axis. So the x's go in the denominator. Now, don't get caught caught up on these itty-bitty numbers. Those are subscripts. They're there because we cannot write the formula y minus y. Because if you wrote the formula y minus y, that would cancel out and leave you no formula. So to distinguish that there's two y values we're going to need and two x values we're going to need, we put the subscripts. What's important to note is this does not mean second y minus first y. It doesn't matter which order you subtract the y's. We just saw that with the picture. Did it matter if I explained the slope from here to here or here to here? No. We both got the same result. So I'm telling you right now, this does not mean second y minus first y. It just means take a y value, subtract the other y value. The most important thing about the formula is to understand the two values are connected by subtraction. The two values are connected by subtraction. So what we're going to do is we're going to take this same point, pretend we don't have the picture, and we're going to do the formula. So what I do to help myself out is I label x, y, x, y, just so I know who's my x and who's my y. The direction said find the slope. So I'm not drawing a picture now. I'm going to use this formula. It says take a y, subtract a y. So I do in order. Here's my first y, 4. I write subtract, and my other y is -1. Now I do the same thing with the x's. I'm just consistent. I go in the same order. If I did this y first, then I'm going to do this x first. So the first x is -2. I'm going to put what operation? Subtraction. And then my other x is -1. So that's all it is. It's a simple substitution. Now what happens is we know two negatives side by side multiply to make a positive. Subtract a negative means to add the opposite. Subtract a negative means to add the opposite. And if you look, 4 plus +1 is 5. -2 plus +1 is -1. And if we reduce that, we divide it, we get -5. Isn't that the same slope we got when we looked at the picture? Yeah, it is. So what I want you all to do is make a connection. If you're not told which way to find the slope, you have a choice to make. If you're a visual learner like I was, I would plot the points and count the rise and the run. If you like to do something on paper, then yes, take the 2 points, substitute them in the formula, get the result. It doesn't matter. They both do the same job. Okay, let's try another example. Okay, so in your notes, there's this next set of points. It says find the slope using the formula. So what I would do is I'd label x, y, x, y. Okay? I say slope is. What goes first? The y values. So the first y value is 3 minus, always put a subtraction, the second y value is 3. Now I'm going to be consistent and do the same thing with my x values. The first x value is -2. Subtract, the second x value is -7. In the numerator, 3 minus 3 is 0. In the denominator, 2 negatives side by side make a positive. -2 plus +7 is 5. But you wouldn't leave that because 0 divided among 5 people is 0. That says the slope is 0. Now what does it mean if the slope is 0? Because we talked about slope being the incline or steepness of the line. If you look back here at the first example, the slope was -5, where it makes sense. If you look at the picture, the line is going diagonally down. And if the slope is negative, we discussed that before, the line should go down. If this slope was positive, then the diagonal line should go up. But what happens if the slope is 0? Would the line go up? No, because that would be a diagonal line. Would the line go down? No, that would be a diagonal line. So we discussed this. What line stays steady? Whose slope is 0? Well, if you look at the picture and plot those points, -2, 3, -7, 3. If you connect them, they make what type of line? Very good. They make a horizontal line. And that's what it means if the slope is 0. It means the line is staying steady. It's not going up, it's not going down. If you had explained the movement from here to here, you would say, I don't go up, I don't go down. So my rise must be 0, but I'm running 1, 2, 3, 4, 5 to the right. 0 over 5 is 5. If I did it this way, if I was here, I would say to get to this point, I'm not going up, I'm not going down. So my rise is 0, but I'm going 1, 2, 3, 4, 5 to the left. I'd have a negative 5, and 0 divided by negative 5 would still be 0. So your answer by using the formula should make sense when you draw the line. Okay, let's try one more. Here are my 2 points. I have an x and a y and an x and a y. And the directions say find the slope. So again, if I use the formula, slope equals, in the numerator go the y values. My first y is 4. I put subtraction always, and then my other y is 8. Now I'm going to do my x values. My first x is negative 2. I'm going to put subtraction. My other x is negative 2. 4 minus 8 is negative 4. In the denominator, these two negatives make a positive. Negative 2 plus positive 2 is 0. Now, you can't leave that. It's a fraction. Fractions mean to do division. We should know our arithmetic skills. What is negative 4 divided by 0? Think about it, sweeties. If I lost $4 and I said divide that into 0 groups, could you do it? No. We've had a long conversation about this before. You can never divide by 0. Therefore, we call this undefined. Now, what that means is the line doesn't have a positive slope, it doesn't have a negative slope, and the slope is not 0. It's not staying steady. So look what I just demonstrated. If the slope was a positive number, we would have a diagonal line going up. If the slope was a negative number, we'd have a diagonal line going down. We just saw if the slope is 0, the line would stay steady, horizontal. What line's missing? Very good. A vertical line. Vertical lines you cannot ski down. Think about that in real life. If you were going to the top of a mountain and I asked you to ski, you would not ski vertically. You would kill yourself. So when you get a slope that's undefined, that doesn't exist, it means we would have a vertical line. Now to prove that to you, I'm going to draw the picture. If I plot negative 2, 4, that'll be there. And if I plot negative 2, 8, that'll be there. And sure enough, I can connect them, they would make a vertical line. And if I said explain the movement from here to here, you would say, well, my rise is down 1, 2, 3, 4, and I'm not running right or left because I'm there. So my run is 0. And that means a value of undefined. There is no number in our number system. If I did it this way, if I said explain the movement from here to here, my rise would be up 1, 2, 3, 4, so my 4 would be positive. But again, I don't need to run right or left, so my run would be 0. 4 divided by 0 is undefined. So what you need to learn is some concepts. Slope is always a number. Slope directly relates to what type of line would have been drawn. Even if you don't draw the picture, you should understand slope could be a positive number, that would be a diagonal line going up. Slope could be a negative number, a diagonal line going down. Slope could be 0, which means I'm staying steady. That's a horizontal line. But if I do my slope and I get undefined, that has to be a vertical line. Vertical lines do not have a number to describe their slope. Okay, and think about it. In real life, you can't ski vertically. You can ski diagonally. Sure, you can go on top of the hill and go down. You could ski diagonally going up. If you've ever been to the ski slopes before, you would realize that to get on the top of the hill, like the bunny hill, you don't have a chairlift. You have to physically walk. And yes, you could ski horizontally. I believe that's an Olympic sport called cross-country skiing. But no way on earth can you ski vertically. So that is why when we do our slope formula, we can get the possibility of 4 things. A positive number, a negative number, 0, or undefined. And that directly relates to the picture. So now we've talked about the 2 ways to find slope. We have one more way. Let's go back to the notes. Okay? The third way to get slope, it says, is to use the equation. And that's what you guys are used to. You're used to me giving you the equation and asking you questions about it. Last module, I was giving you the equation and asking you to tell me what type of line it is and to draw a picture, graph it. Today I'm going to give you the equation, and I'm not going to ask you to draw a picture of it. I'm going to ask you one thing and one thing only, to tell me the value of the slope. So the important thing is memorizing concepts. And there's no easy way to do this, guys and gals. You have to memorize. If the diagonal line goes up, the slope's going to be a positive number. If the diagonal line goes down, the slope's going to be a negative number. If the line is horizontal, it's not going up, it's not going down, it's staying steady, the slope is 0. And if the line is vertical, the slope is called undefined. It doesn't exist. So let's look here. I believe we have 3 examples, so let's go to the whiteboard on this. Okay? So, we have 3 equations. F of x equals 6. X plus 4 equals negative 9. 3x minus 4y equals 12. Why are they all equations? Very good. Going all the way back to Module 1, an equation has an equal sign. Now, I'm not asking you to draw a picture of these, but I'm telling you, you can never answer a question about graphing till you first make a decision. And the main decision is, because we're graphing lines, you should be able to look at these equations and tell what type of line it is. From the last module, we've already discussed this. You know by looking at the variables what type of line it is. If a line only touches the y-axis, it's horizontal. So that's why if we see just the letter Y, we know it's a horizontal line. If a line just touches the x-axis, it's vertical. So see, I'm only touching the x-axis. I'm vertical. That's why its equation only has the letter X in it. And if a line touches both axes, the X and the Y, it's going to be diagonal, whether it goes up or it goes down. If it touches both axes, it's diagonal. That's why its equation will have both variables, x and y. So here we go, guys. Before you ever do anything with graphing, before you even try to answer the question, we've already discussed this. Decide what type of line it is. So when you're given an equation, decide which line it is. Well, out of all 3 of these, it's very obvious. Number 3 has an x and a y. So we know that this is a diagonal line. Equation 2 has just the letter x. So that must be a vertical line. Now, equation 1 doesn't have an x. It has an f of x. We've already discussed this. This is called function notation. It is just a way to name something. Remember I called this Fred? I told you over and over again, anytime you see function notation, cross it out and put in place of it the variable y. So anytime you see something named f of x, and we're talking about graphing, cross it out and put what variable? Y. Well, now this says y equals 6. If you just have the variable y, it's a horizontal line. Now that we know which types of lines these are, we're going to answer the question. The question did not say draw a picture of it. The question says find the slope. When they ask for slope, they're asking for an answer that's a number. So all I want to know is what m equals. Well, if you know for sure y equals 6 is a horizontal line, which it is, because if you drew a picture, you go to the y-axis, to the number 6, you'd plot a point, and then you would draw your line. You could now tell me the slope. Is that line going up? No. Is it going down? No. It's staying steady. What number shows the slope is staying steady? 0. So you have to memorize this fact. Buy yourself some index cards, write these facts down. If it's a horizontal line, what is always the slope? 0. You won't see the 0 in the equation, you just got to know that the slope is 0. On the second equation, we had an x, so we know it's a vertical line. If I asked you to draw the picture of it, you're right. You would subtract 4. You would get x equals negative 13. So you would go to the x-axis. You go to negative 13, which is somewhere back here. You'd plot a point and draw a vertical line. Okay? Now, if you look at that, it's vertical. It's not staying steady. You can't say the slope is 0. What you got to remember is slope is talking about movement. No one is going to move vertically. If you skied vertically, you would kill yourself. So we talk about this. The slope of a vertical line doesn't exist. It's undefined. You have no work to do. So anytime you're asked the slope of a vertical line, that's always the answer. Put that on an index card. The third equation, though, is diagonal. It has an x and a y. Well, we already discussed this. To draw a picture of it, it'd have to be in what form? Good. It'd have to be in slope-intercept form. What is slope-intercept form? Awesome. It's y equals mx plus b. We discussed this. Anytime I want to know anything about a diagonal line, you must get the variable y by itself. So to get y by itself, we're going to subtract 3x. We're going to get, watch your signs, negative 4y equals, we're going to put the x part first, so that's negative 3x, and that's a positive 12. Do we have it in slope-intercept form? No, we do not. The y is not by itself. So to move the negative 4, we have to do division. And if we divide one term by negative 4, we divide all the terms by negative 4. Okay, we did this in the last module. The two negative 4's cancel out. There's the y equals. 3 doesn't divide by 4, but a negative over a negative is a positive. So that's 3/4 x. 12 divided by negative 4 will divide and gets negative 3. So in the last module, once you got the diagonal line in slope-intercept form, you were able to draw the picture of it. So if I asked you to draw a picture of this, you'd be fine. You would know what number is the slope. Good. The m, which means multiply, is 3/4. What number is the y-intercept? B means behind. That's negative 3. So if I asked you to graph the diagonal line, just to review, do we use slope first or the y-intercept first? Very good. B means you begin on the y-axis. So we begin on the y-axis at negative 3. The slope is 3/4. That explains our movement. Because 3 is positive, we would go up 1, 2, 3. And because 4 is positive, we go to the right. 1, 2, 3, 4. And do you agree that makes a diagonal line? Now, I didn't have to do that. I just want to make sure you review what we did in the last module. The directions in this module just say find the slope. Do you really need to have the picture to explain the movement? No. You knew the slope was right here. Once you get the equation in slope-intercept form, you know the slope. So we would just say for this one, the slope is 3/4. I understand this line's going to move up 3 to the right 4 to make each of the points. So that's how you use the equation to get the slope. If the equation is horizontal or vertical, there's no work. If the equation is a horizontal line, the slope is always 0. If the equation is a vertical line, the slope is always undefined. But if it's a diagonal line, if it has the x and the y, you have to isolate y to get the number for slope. So far, so good? All right, we got one more thing to talk about. Let's go back to the notes. Okay, so now that we know the 3 ways to find the slope, we have one more concept to talk about. We're going to talk about these 2 words, parallel and perpendicular. And you've heard of that before in a geometry class. Look up here at my picture. Parallel means the 2 lines are never going to touch. They're never going to intersect. Now, you can't just judge by your eye if 2 lines are parallel. Remember, lines have arrows on the end. They extend on forever and ever. Eventually, they could meet. So we have a rule. The way you know lines are parallel is they're going to move the same way. And that word move is your slope. So if you look at your first line, the equation is y equals negative 2x plus 4. And that makes sense. The y-intercept's at 4, and they went down 2 to the right 1, down 2 to the right 1. And that's how they formed that line. The slope is what number? Negative 2. If you look at the other line's equation, y equals negative 2x minus 3, we know by looking at that equation the slope is negative 2, the y-intercept's negative 3. So to graph that line, they went to the y-axis to negative 3, and they still moved down 2 to the right 1, down 2 to the right 1. What was that line's slope? Good, it was negative 2. What I want you to notice is both of those equations have the same number for slope. What's their number for slope? Negative 2. If two lines' slopes are the same, that means the two lines are moving the same way. And if you move the same way at all times, you're never going to touch. That's how you tell if the lines are parallel. They would have the same number for slope. So, if I told you my line slope was 5, and you're going to be parallel to me, what's your line slope going to be? Very good. It's also going to be 5. Because if we're parallel, we're going to move the same way. We're going to have the same slope. Let's look at the next picture. This is a picture of perpendicular lines. Now, perpendicular means they're going to intersect. Intersect means touch. But they don't just touch anyway. They touch and form a 90-degree angle, a right angle. So if you look at that picture, it is obvious those two lines do intersect. And if you look, the angles formed are 90 degrees, just like when the x and y axis intersect. They make 90 degrees, the little box. Well, again, you can't let your eye be the judge. To know if those lines are really perpendicular, there's a relationship with their slopes. So look at the first equation. Y equals 4x plus 1. The y-intercept's at 1, so we went to 1 on the y-axis, and then the slope was 4. So we counted up 4 to the right 1, and that's how we drew that line. The next equation is y equals negative 1/4 x minus 3. So we went to the y-intercept of negative 3, and that slope meant to go down 1 to the right 4. And that's how we got that line. If you look closely, are the slopes the same number? Nope, they're not. If you look closely, the numbers for slope have a special relationship. One slope is 4. The other slope is negative 1/4. So there's two things going on. The first thing you'll notice is they're opposites of each other. The opposite of a positive is a negative. So two lines that are perpendicular, their slopes are always going to be opposite. But they're not just opposites, they're also reciprocals. What does reciprocal mean to do? It means to flip the fraction. So if you look, the first equation, its slope was 4. That's 4 over 1. If you flip that, do the reciprocal, the other slope is 1 over 4. So we say if lines are perpendicular, their slopes are opposite reciprocals. So let's try an example. So if you look here, we're going to go up to the board, we're going to look at this example. So let's go to the whiteboard. Okay, I'm giving you 2 points. Point A is at 2, negative 4. Point B is at negative 2, negative 16. And the direction says find the slope. So we just learned there are many ways to find slope. We could plot these points and count boxes. But here I am, I have a problem. Does my graph go up to negative 16? I mean, go down to negative 16? No. So I can't use my graph paper for this. So the way I know I can find the slope here is to use the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is basically just remembering rise over run. So if you look, I'm going to label who my x and my y are. So I'm going to do my formula. I'm going to subtract my y's. I'm going to subtract my x's. So my first y is negative 4, and I'm going to subtract that from negative 16. Then I'm going to do my x's the same way. My first x is 2, and I'm going to subtract it from negative 2. Doing our arithmetic, 2 negatives make a positive, 2 negatives make a positive, and now look what we get. Negative 4 plus 16 is 12. 2 plus 2 is 4. And 12 over 4 is 3. So the slope, the movement between these 2 points would be up 12 to the right 4. Or simply, up 3 to the right 1. Now, the question A says, find the slope of a line that would be parallel. So if I plotted these 2 points and I wanted a line that would be parallel to this, parallel means it would move the same way. Well, that's very simple. If you're parallel, you're going to be the same slope number. What is the slope of this line? 3. So the slope of the line parallel would also be 3. It would move the same way. On part B, it asks for the slope of the line perpendicular. Well, if you're perpendicular, you're going to want to cross, which means you're not going to move the same way. The rule is if you're perpendicular, the slopes are opposite reciprocals. So if you look, this slope is 3. If I'm going to draw a line perpendicular, my line's not going to move up 3 to the right 1. It's going to move opposite, which means it's going to be negative. And it's going to be the reciprocal of 3, which is 1/3. So a line that's drawn perpendicular would move down 1 to the right 3. It would be the opposite reciprocal of this slope. Is everybody with me on that? So that's the key. You've got to memorize that. All right, we have one more example to look for in our notes. This one I love. It says, determine if the lines are parallel, perpendicular, or neither without graphing. And here's where we like shortcuts. Let's look at the first equation. We are given in A, y equals x plus 1. We're also given y equals negative x plus 1. So look, let's put the whole chapter together. If you look, these are both equations of what types of lines? Diagonal. They both have an x and a y. I could ask you to get out the graph paper and graph them and look and see if they're parallel, perpendicular, or neither. You don't need to do that work. The concept is anytime you hear the word parallel and perpendicular, there's a relationship with the slopes. So now let's use what we learned. Can you look at this equation and tell me the number for slope? Slope stands for m. M means multiplied. What's multiplied to x? 1. How do you write slope as a fraction? 1/1. Let's look at this diagonal line. Slope stands for m. M means multiplied. What's being multiplied to x? -1. How do you write that as a fraction? Put it over 1. So now look, are these the same number? No, they're not. Are they opposite reciprocals? This is positive, this is negative. That's an opposite. If we take 1/1 and flip it, we would get 1/1. These slopes are opposite reciprocals. And the rule is, if the slopes are opposite reciprocals, without drawing the picture, I know when if I draw these lines would be perpendicular. They would crisscross at 90 degrees. Now I'll prove it to you. If we go to the board and I graph this line, the y-intercept's 1. The slope is up 1 to the right 1, up 1 to the right 1. And there's that line. Okay? If I draw this line, the y-intercept's still positive 1, but the slope is down 1 to the right 1, down 1 to the right 1. If you look very closely, these lines intersect, and right there is a 90-degree angle. I don't have a problem with you drawing the picture, but you don't need to. If you want to know if the lines are parallel or perpendicular, all you got to do is look at their slopes. Let's look at the next example. Okay, I have two equations. I have y equals -2x plus 1. And then I have 2x plus y equals 5. Okay, we're always going back to the basics. If I give you an equation, what type of line it is? They both have an x and a y. They both got to be diagonal. If they're diagonal lines, they always have to be in what form? Slope-intercept. Is this in slope-intercept? Sure. Then you should see the number for slope, the number that's being multiplied. That's a -2. We always write it as a fraction. Is this equation in slope-intercept? No, this is called standard form. We got to move it around. So to get y by itself, we're going to subtract 2x, subtract 2x. Y equals, put the x first, and then that's a +5. Now do you know the number for slope? Slope is m. M means multiplied. We got a -2. Write it as a fraction over 1. Now, I don't need to draw these lines. I have enough information. If this slope means the line's moving down 2 to the right 1, and this line slope means you're moving down 2 to the right 1, they're moving the same way. Think about it. If you had a point here and a point here, if I move them both down 1, 2, and to the right 1, they will not touch. If you move the same way, if your slope's the same, that guarantees your lines are going to be parallel. So that's all I need. Knowing those slopes will tell me if I draw these two lines, they'll be parallel. They'll never touch. All right, we got one more example. So our last example, we have two equations. We have x plus y equals 5, and we have 2x plus y equals 5. What types of lines are they? It has an x and a y, it's diagonal. Has an x and a y, it's diagonal. Every time you deal with a diagonal line, what form does it need to be in? Slope intercept. All right, let's get them in slope intercept. Let's subtract x. Y equals, the x goes first, it's a negative x. That's a positive 5. Do you know the number for slope? Yep, it's the number being multiplied to x. It's negative 1. We write it as a fraction. The same thing over here. It's a diagonal line. We're going to subtract the 2x. We're going to get y equals negative 2x plus 5. What number's the slope? It's the number being multiplied. It's negative 2 over 1. Everybody look. Are these moving the same way? Do they have the same slope? No way. This line's moving down 1 to the right 1. This line's moving down 2 to the right 1. Well, if you think about that, they would eventually touch. If I move down 1 to the right 1, and this one's moving down 2 to the right 1, they're eventually going to collide. So these are not parallel. Are these going to be lines that are perpendicular? Well, to be perpendicular, the slopes have to be the opposite reciprocal. Are they opposite of each other? Nope. That's negative, that's negative. So that's not what it is. So we would say these two lines are neither. Now, what does neither mean? Neither means that when you go to draw a picture of these two lines, they would intersect, but it wouldn't be at 90 degrees. So if you drew a picture of these two lines, they would touch, but you would get either an obtuse angle bigger than 90, or you would get an acute angle less than 90. So what we talked about today only is this concept of slope. Slope is a key concept for lines. It's the movement from point to point. There are 3 ways to find the slope. Yes, you have to know all 3 ways. I'm visual. I like to use a picture. If I can't use the picture, I have a formula. Or I can use an equation. And then we discussed if lines are parallel or perpendicular, how their slopes are related. Okay, we have one more module in this section. Talk to you later.